Okay, there we go. I think it is recording, so I will present my EE201 final. And basically, this is the final project. This is what I probably would have done if given um, the chance to do the final project or the take home exam, but luckily both were given, and I really wanted to show this because it's really interesting in my aspect. I really wanted to use the 7 segment display, so doing this I got to use it, so that was really nice. I'm Jaron Sandbeck. This is EE201, and it's for my project was an automated security system. So the main description is that it will be an automated security system that's monitoring a given area with 6 cameras on the perimeter of an area. Think of like a construction site that you need to keep a watch on, or a house that it's like really fancy that you need to make sure no intruders. And the best part about this is that the owner can manually adjust how often each camera switches to the other, and this does this via the clock. Um, and I also put in an error light, which indicates that the cameras are having any trouble, and the error light is independent of the cameras, so the switch that turns that on doesn't run with the cameras, and thus it will always pop on no matter if the cameras are completely off or something like that, which is nice. So A is the error input, C is the clock for the time frame. So here's the two truth tables. One's a counter, one's a decoder. And so basically I ignored QD because I only would need 0 through 7. This is going to be a later problem with 8 and 9 being included in this decade counter. And then the decoder was an active low decoder, as I found on the internet, with the 74LS138 decoder. So here's this, here's what it'd look like. And so because of 8 and 9, with QD being excluded, it will go back to 0 and 1. So 0 and 1 will repeat twice, basically. And so my biggest explanation that I could do, because this project involved like wiring a lot more than equations, there really was no equation besides maybe one, and I might include it after this presentation, but there was one equation for the error light, which would just be Q, A, and DIO 0. And DIO 0 is the input. Um, yeah, but the way it worked is that there was a counter that would turn the clock output into a binary, clock input into a binary output. And then I had another decoder that turned the binary output into 7 or 8 different variables based off of the binary input. So that was nice. And so the outputs of the decoder allowed me to input Y0 to Y6 into A through F on the 7 segment display, respectively. And because of the decade counter, yes, 8 and 9 were also counted, which would become a later problem. But here's the circuit display in multisim. I really only needed 3, um, well, 4, I guess, if you count the 7 segment display. But here's the AND gate. Here's the truth. Like, here's what it would look like for the error light. That would be independent. Here would be where the cameras are technically running right here. And here's where the cameras are. So it is independent of that. Red LED shows that there's an error going on. It will flash too. Now, the biggest thing was troubleshooting. During building this, I actually put one of the chips upside down, and because of this, it overheated very fast. And even though it sent an error message, power was still running through it. And if I looked on my computer, I could see it going from 37 all the way down to 29 before I figured out what was wrong. And by then, the chip was very, very hot, and I could smell stuff. So that was lovely. And the second problem was that because of there's 6 inputs in the 7 segment display that I'm using, I could have just used Y2 to Y7 and just forgot about the repeated Y0 and Y1 with the decade counter. So even though I didn't fix it, it still works as I wanted it to. And here's me testing my prototype. Now I'm coming towards the end of the video, the 5-minute video, so it might cut me out here. But basically, up top is the counter for the clock, and then it turns it into a binary. Binary then turns it into Y0 through Y7, and I plugged it in to here to basically make it so that the lights would go around the perimeter. As you can see from the video that I posted, if you click on the video or if you copy the video, you'll see. And then here's the red LED light that's independent.